the rule book was written, arguably, in sort of some of the heyday of coral reef science in the 1970s and 1980s. And those rules worked in the 1970s and 1980s. We knew what a storm would do. We knew what an outbreak of predators would do. We knew what bright sunlight would do to photosynthesis. And now it's changed because the water is hotter.
You've watched coral for nearly 40 years off of the Earth's Virgin Islands, and then an additional 20 plus years in French Polynesia. What lessons have you learned that have been reinforced during that period of time? So you had a hypothesis 40 years ago, and those always change because hypothesis is not fact, it's a hypothesis. What questions got answered, and what new questions arose during the course of those 40 years as you've looked at coral?
There's been a lot of questions and a lot of answers. I mean, I think I just wrote a new article that tried to forecast how ideas have changed, and that's one of the values of long-term research. I think initially when I started the work, I was so young. I was so young and naive. I thought that you'd have a coral reef and then you'd have a storm, and that would set in a spiral of death, and that would be the end of it. And so I think one of the major things I've learned is how resilient coral reefs are. They can grow back, but they grow back very differently. And I think also what I've learned is no matter how much you think you know, you don't know enough. And I think what I've learned, what I'm seeing now, I've got all this data from this project. It feels like the rule books are changing faster than we find the facts that we try to understand. And so 30 years ago, the rule book would have said, well, my goodness, you have a beautiful coral reef and a big hurricane comes by, that will kill off the corals, and then maybe 5 or 10 years later it will regrow. Now the rule book has to be written in a different way because the coral reef is less well developed. The storm comes by, and you know what? You can't detect the effect of the storm. And that's not good news. It's actually quite worrying news because the reef is so debilitated, there's so little of it left, you can't measure what has actually died off. And so the rules are changing. And recently one of my colleagues, we don't need to do any more coral reef science because we know now what happens. Coral reefs are dying and storms are bad and hot water is bad. And I was absolutely flabbergasted with that response. Like, oh my goodness, no, that is so far from the truth. We've learned that the rule books are changing faster than we can try to interpret them. And that's why we need to keep doing this work.
Isn't that also the reason why 40 years of data tells you the map is changing, the rules are changing, but they're not telling you all the answers of why they're changing and what that change means yet.
Well, that's the key part. I like to think of my work having 3 components, the three P's of science. 1 is recording the pattern, which is how things have changed. 2 is trying to look at the processes that cause those patterns to change. Why is it that some species do well? What's the mechanism there while other species die out? And the 3rd P is projection. We're trying to take what it is that we know now to project in the future. And so I think the danger of getting those projections wrong is very, very acute. I want to be as right as I can possibly be with the information I've got. When I say to a school group, my goodness, there will not be coral reefs for your children to visit when they're grown up, I want to be fairly confident I'm right. If I'm wrong, I need to say something else. And that comes from projection. And projection is very, very tricky. And you can't simply take a line from the present condition and draw it ahead of you and say, well, that's what will happen in the future with a straight line, because the world is not a straight line. It's a convoluted and tortuous pathway, and you're trying to predict what causes that pathway to turn. And that's the projection. That in some ways is the hardest part. Like Yogi Berra said, telling the future is difficult when it's in the future.
But I'm just thinking about one of the papers you've written over the years where the stony coral were dying off, but the soft coral were going in. That meant the neighborhood was changing, but didn't mean the neighborhood was gone.
Right. That's what I would call a classic shifting baseline. And so as a vacationer, you go to the Virgin Islands, you may have never seen a coral reef before, you put on your mask and your fins and you kick out there and you're blown away by how beautiful it is. And yes, it is beautiful and it's worth cherishing and it's worth supporting and it's worth trying to raise money to keep it beautiful, but it's not what was there 50 years ago. And I think, while we look at what is there now and we value what is there now, we have to sort of recognize what has been lost as well.
We need to recognize what's been lost, but at the same time, what's there is surviving in the now.
Right.
The environment of 50 years ago doesn't exist in that spot anymore.
I fear you're right. And that kind of comes back to the rule book. The rule book was written, arguably, in sort of some of the heyday of coral reef science in the 1970s and 1980s. And those rules worked in the 1970s and 1980s. We knew what a storm would do. We knew what an outbreak of predators would do. We knew what bright sunlight would do to photosynthesis. And now it's changed because the water is hotter. The water is a little bit more acidic. Storms are turning up every 5 or 6 years instead of every 10 or 15 years. So the old rules, broadly, there's lots of gems of knowledge there, but they don't quite apply the same way because the world is different. And that's one of the big challenges, that what worked in the past won't necessarily work in the future.
So your research isn't saying climate change doesn't exist. Your research kind of has demonstrated it does. But your research is also, I always say your research always makes me ask more questions than we have answers for yet. But it's also saying it exists. We can't undo it. We can't change the acidity of the water. It's done. It's not like we can take a giant paper towel or I don't know what, do a chemical process and clean all the oceans of the world. It's not like they're also in a little beaker. They mix. The water mixes. You can't stop that water.
Well, first of all, in terms of climate change, I think when most of us hear about climate change, it's coming as a diffuse concept that somebody has measured, whether it's NOAA or whether it's satellites or whether it's some unknown group of people have measured something happening. And for me, one of the things I've very much enjoyed about my work, I have seen the data roll into my notebooks. I've seen the data appear in my computer file. When I look at the temperature records in my computer, I have collected every single one of them. The only person I know who would have screwed up is me, and I'd make mistakes, but I'm pretty confident in what it is that we do, and I look at those records. I collected them. My team collected them. Grad students from CSUN helped me collect them, and I look at them like, oh my goodness, the water has got hotter. It's not this obtuse concept. It's very personal to me. I know the water is hotter. I've measured it. So I'm a believer. I'm an optimistic believer. I would like to think that we still have the potential to change the world, to create conditions closer to the way they were. It'll be exceptionally hard, and we won't be able to snap our fingers and make it happen tomorrow. But I think there are actions that we can take that will slowly reverse those changes. I cling to that notion. I don't expect it to happen anytime soon. And I would hope that we can take sort of remedial actions that will make the future less bad than it could be. And I think there is the potential to change the endpoint. You have to believe that, or else you'll get a little gloomy.
What are some of the actions we should, you were working with young people, which is a gift. I hate to say it, but those are the people who can affect change. What are some of the things that we can do we can't end it, but we can mitigate it?
In the course of my career, I've had some wonderful examples that have really warmed my heart. I had a student that contacted me a few years ago who said, well, you won't remember me, but I was one of your first students in 1987, and now I'm an investment banker in New York, and I have a client who wants to invest socially responsibly and in the environment. What should I do? What should I tell them to invest in? And I thought, oh my goodness, this is awesome. This is what I've been spouting for decades in the hope that some of the young adults I will speak to will become leaders of corporate America and businesses throughout the world. And when the decision lands on their desk, they could do something environmentally good or they could do something environmentally bad, then they pick the good option. And that's really super encouraging. But I think in terms of sort of an everyday effect, I think one of the things that worries me now is young adults buried in a virtual world. And one of the passions I have in my research and my teaching is getting young adults into the environment, to climb on rocks, to go snorkeling, to look at the natural world. If you don't understand the natural world, you're not going to do anything to save it. And so I feel one of the really important things that we can do in schools and universities and colleges is create frameworks where young adults can get an environment to appreciate nature. And then once you appreciate nature, you see every single day you have choices that are right and they're less right. I don't want to say they're wrong, but they're less right. You can choose to buy water that's bottled in your own community, or you could choose to buy water that's flown in from Fiji. You could choose to buy a local apple, or you could choose to buy a pineapple brought in from the other side of the world. And all these things have consequences. And so I think, charity does begin at home. You can start with single choices that will help to make the world a better place.
You work at an urban university, so one thing, we're not next to the ocean. We got to drive out there. We're not that far away, but still we're actually surrounded by mountains that you have to cross to get over to the beach. And you also deal with your students are urban students. So many of them have never gone scuba diving until they choose to major in marine biology. What is it like to see the impact your education have on these students?
Sometimes on my dark days, I think, well, my goodness, I've written a lot of papers in 40 years, and, I'm not really sure whether people read them. And if they read them, I'm not sure whether they really take note of what I said. But it's the students that I've interacted with. They are by far the most valuable thing that I do. The young lives I change, the people I turn on to the natural environment, and just making students feel comfortable going, if I can help generate a group of students who, when they are parents, they feel confident to take their kids into the field and have their own kids climb on the rocks and not be afraid of slimy stuff and not be scared of really weird little animals, then that will have been a tremendous success. So I love turning young adults onto marine biology, just the excitement of looking at snails, the excitement of looking at crabs, the excitement of looking at fishes. I mean, it's infectious. It's such a wonderful experience.
You have had research projects that you've actually incorporated local high school kids. That's part of your spreading the word, but they've done research with you. Yep. What was that like?
It's a different experience. I enjoy working with high school students. I enjoy working with high school teachers. It's part of the bigger program. I think they bring rewards and they bring challenges. But again, it's an inspiring experience working with kids and helping them understand the natural world. It feels like you're working with modeling clay. They're so malleable, and you can sort of push them in different directions and alter their perception of the world and make them feel they can aspire to things that previously they thought were unobtainable. And again, that's a tremendous sort of reward. I really love that.
Now, you mentioned and you referred to yourself as optimistic. Why? I know, but I want to hear a little bit more. What are you hanging your hat on?
I'm optimistic because I'm an optimistic sort of guy. I'm just a simple caveman. I like going out. I like running. I like being in nature. There's a lot to love in the world. I'm not into fancy cars and expensive things. I love the natural world around me, and I don't see how you can look at the sun and how you can look at the ocean and how you can look at the hills and not be optimistic about it. And that's what I hang my optimism on. And I hang my optimism on the thought that tomorrow will be better than yesterday. And we do retain the capacity to change the way things are. And I'm also optimistic because in my heart, I know we cannot give up. If we give up, then that will be really bad. And a number of years ago, I went to a coral reef talk by a very well-known biologist. And he said, well, I think we have succeeded too well. We're succeeding in convincing people that coral reefs will die, that coral reefs will be gone. And he said, you know what? That's wrong. We can't do that, because if people think coral reefs will be gone and they'll die off, or if they think if any other ecosystem will be gone, then they won't do anything else to protect it. They won't vote people into power in politics who will do the right thing. They won't do the right thing with their own life choices. And then we are really doomed. And I thought that was a really good point. And so I think it's important to both accentuate what we've lost, but make people feel that, there's a lot of cool stuff out there, a lot of things to value, and tomorrow can be different. You have choices that you could make that will help to make the world different.
I keep thinking, I keep going back to the neighborhood analogy. It's been 40 years. The neighborhood is going to change in 40 years. That's just the nature of life. I mean, I bought my house 31 years ago. My neighborhood has changed in those 30 years. And you would call me naive to expect my neighbors and my neighborhood, the houses in my community, my little community, to remain exactly the same. So in this instance, the neighborhood is changing under the surface of the water. The question is whether the neighborhood gets wiped out or we adapt to the new change. It's pretty much what you're saying.
Well, I think one of the sobering reminders I stumbled on in the last couple of years is that this is the first time in the history of our planet when the major source of disturbance in our planet are humans. Before, it's been giant eruptions, it's been asteroid impacts, it's been giant diseases, and now humans are the major source of that change. And so we're driving the changes in the neighborhoods around us. And change is part of evolution. It's how the world has evolved and why we have got what it is that we have now. But as humans, we have an awesomely, distressingly large ability to change things in ways that we won't really like. And so, I think that's what we're trying to record, to make people aware of that, to make people of the options to change it in different ways. And like they say, extinction is forever. So when that does happen, if we do mess this up, then there's no going back. There's no making those things appear. And I think another wonderful thing I've learned from my work is I think coral reefs are a little bit like, and you've heard me say this before, they're like a really large jigsaw puzzle. And you've just spent months assembling this huge jigsaw puzzle on your coffee table, and then suddenly in come your little annoying nephews and nieces, and they just run around, they push all those jigsaw pieces off the table, and it's like, oh my goodness, you destroyed my puzzle. And we're at that point right now, and all those pieces of the puzzle are still in the room. They may be under the table, they may be tucked under the carpet, may have slipped underneath the bookshelf, but if we look hard enough, we can find them. And if we can find them, we can put them back together again. But I don't know how much longer those pieces will be there. Sooner or later, we'll start losing those pieces. And that's a time that worries me.
Your 40 years of research is helping to lay that foundation of how to put those puzzle pieces together, though.
I would hope so. I mean, if you really look into a dystopian future and you think, where will we be in 100 or 200 or 500 years, it's not unreasonable to think that we will need to be able to make ecosystems. And we may be at a point where somebody will say, you know what, we need you to build a coral reef because we don't have any coral reefs left. What we've got is genetic material and we've got a bunch of cement blocks and we'll need to rebuild it. And so, perhaps my life's goal is to know enough about a coral reef to build it in its entirety. And I don't mean building a little coral reef in a 3-foot-long, sort of 1,000-gallon tank in your living room. I mean building the whole thing, that we know enough about the biological interactions, we know enough about the environment, we know enough about evolution that we can actually build that system. We're a long way from doing that. And I say that not because I want to, but because we may have to in the future. And I hope we never get there, but I think it's important to think about that as an endpoint.
Just thinking of all that data you've collected and what makes it so amazing, it's from the same spot. It's not data collected over here and data collected over there, which may or may not be interconnected. It's from the same spot, which really can give you so much information about what was there and what happened during that arc of time, which makes it amazing. It's invaluable.
It is, and that again is in large part what fuels me to make me want to keep doing it and do more of it. Because in some ways, the forces sort of mustered against sort of climate change and the notion that the world is changing, they're pretty strong, and you want to be sure of your facts. I don't want to think at the back of my mind, well, my goodness, I don't think I've quite returned to the same reef, or, oh my goodness, I don't think I'm taking the photograph in the same spot, and maybe that's why the reefs look different. I don't want to have that at the back of my mind, and that's why monitoring and time series and returning to the same spot is so important, because my job, once again, all I've got to sell other than trying to educate young adults is to be able to tell the truth the best I can. And the truth evolves over time. And the best way I can be confident of what I'm telling you and everybody else is I have gone back to the same spot every single year. I was there during the hurricane. I was there during COVID. I was there during medical challenges. We were there at the same spot every single year. So I know how it's changed. There's no doubt in my mind.
I think that's it. Dr. Edmunds, thank you so much for joining us today, and thank you all for joining us for diving into the discourse.